Hey everybody, how's it going? My name is Hunter, and in today's video, we're starting a new series called The Lab Project. And I guess the first season, you could call it, of this series is going to be focused on the ENARSI, or Implementing Cisco Enterprise Advanced Routing and Services. Man, that's all I have to say. Certification, or specialty exam, which is the most popular concentration specialty exam under the CCNP Enterprise track. So for those of you guys who do not know already, I already am CCNP Enterprise certified. It was rolled over from CCNP Routing and Switching. And the reason I'm starting this series essentially is because I am just now starting to pursue my CCIE Enterprise Infrastructure certification. And with that, I'm doing tons of labs, a ridiculous amount of labs. So this is actually, a win-win for both of us. I'm getting some good lab time in here by building these topologies out, and then you guys are getting a free resource to study for your ENARSI exam. Okay? So this series is essentially going to be about trying to integrate as many exam topics from that ENARSI blueprint into this one topology as possible. Now, some topics we're going to have to make some adjustments for, such as more advanced BGP with MPLS, using route reflectors, things of that nature, L3 VPNs. It's not feasible with a topology this size. We're going to have to dedicate a lot more routers to really get an effective lab out of that. But we should be able to cover a ton of the exam blueprint with this one topology here. So we're going to start off by building the initial configurations. So we're going to be getting all the interfaces configured. We're going to be getting the transport up, the DMVPN tunnels, the core routing protocols up in this video. And then in future videos, we're going to be adding additional things on, such as access lists, policy-based routing, route maps, things of that nature that are going to come with time. But for this video specifically, I just wanted to kind of get the foundation built here so we can get you guys labbing. And with each video that we release, we're going to actually be coming out with some labs that go along with each one. So these could be troubleshooting labs or change requests, I guess you could say, where I say, hey, I want this to do this, or I want this route to go this way instead of that way, things of that nature. All right. So with this first video, though, this video is probably going to be about an hour long. I assume it's going to be an hour long because I can't stop running my mouth. So I don't want to make the video an hour and a half long by throwing the lab video on as well. So this video is going to be us setting up this lab, getting it initially configured, getting to a good stopping point, and then the next video is going to be a lab based on where we get to at this point in time. All right. We're going to have multiple troubleshooting tickets, potentially some change requests in there, but I would recommend, again, taking this topology and then building it out with me, and then having the topology, making a copy of that topology, and then opening it up again, clearing the configurations out, because for the troubleshooting tickets, you're just going to paste in my configurations. You don't want to paste over top of the already existing topology, because some of this stuff might not take. It might not be as effective as if you just paste it into a blank router. Okay, and then you're going to have to make it work the way that it was working today. So something's going to be broken, something's going to be misconfigured. There's going to be some kind of issue that it's going to be up to you to troubleshoot and figure out what that is. And then I'll obviously have the explanations and my thought process on troubleshooting it with the video as well. Because as you guys know, most of the exam topics on the ENARSI blueprint are troubleshooting and configuring, right? And I have heard from Little Birdie that there is no actual simulations on the exam. However, I would probably prefer there to be simulations, right? Because at least with simulations, you can question mark stuff, typically. So that means that, if this is anything in comparison to T-Shoot with the old exam format, then, you're going to need to know that syntax, because a lot of the questions with T-Shoot, if they weren't actual troubleshooting the exams, troubleshooting the simulates, it was a specific command that you would run in this specific scenario, right? And they all look very similar. So if you haven't been drilling that syntax into your head by actually doing it in a lab environment, just reading it once isn't going to cut it, okay? We're trying to set you guys up for success here. So make sure that you're actually doing these labs, because regardless of what's on the exam, regardless if the exam doesn't even ask for specific syntax or doesn't ask for specific troubleshooting techniques, in a practical application scenario, if you're going to get a new job or you're trying to move from a network administrator to a network engineer, whatever that may be, you're going to need to know these commands, and you're going to need to know this, they're going to expect you to know how to troubleshoot when you get to your place of employment. Okay, so not in front of my mouth, taking a look at the topology here, you can see there are only 20 nodes. I intentionally kept this under 20 for those of you guys out there who are running CML personal. I know you guys pay a lot of money for that, so I don't want to take that away from you. 20 nodes limit is the max over there, so I wanted to keep it under 20 nodes so we can be fully inclusive here. We're also running IOSV images, so those of you guys who are running EVE-NG GNS3 using those Cisco viral images, or CML images, I guess you could call it, you're going to be able to run that here. That's what we're using. That's what my configuration is going to be based off of. So if you have that image, you can run these labs. All right. Doesn't matter what emulation platform you're using. Cool. All right. So I do highly recommend, though, that you guys actually take the time to build this topology out with me today. so you can actually get an understanding of what we have going on here. So when it comes to actually troubleshooting these tickets, you know what it's supposed to look like, you know how it's supposed to work, and you can kind of, it'll help you out with attempting to fix it, right? Now, going in blind is also good practice as well, so just copy pasting. But at the end of the day, like I said, my diagrams aren't going to have enough detail in them for you to be able to really figure out what everything is that we have going on, what the commands are specifically supposed to be, unless you were to compare them with the good configurations. All right, enough of me running my mouth. Let's go ahead and take a look at the topology here and kind of see what we have going on. So the idea here is that we have company A on the left, which is site 1, company B on the right, which is site 2, and these individual sites down here are shared workspace environments. So this could be one office building with multiple floors holding different companies, and they may be sharing the same ISP CE edge router, okay? So all their traffic is going eventually into the same router. Now we want to make sure the companies, they have specific policies where they want to make sure the control planes of this traffic is completely separate than each other, okay? And we can actually do that by implementing VRF Lite, which is what we're going to be doing down here. VRF Lite is the same thing as VRF, it's just when you're running it without MPLS, okay? So we'll be not only splitting these up and literally separating the control planes here, we're also going to be running DMVPN to each one of the sites. So all the traffic is actually passed strictly through that DMVPN tunnel, okay? And additionally, we're going to be running IPsec on those DMVPN tunnels as well, which is, again, part of the exam blueprint. We're just going to be doing very basic IPsec on these, nothing too crazy. We'll save the craziness for CCNP security. But again, the traffic will be separated, it will be encrypted, so anything passing over this transport network here, there's no visibility into those packets, okay? Now, the transport network. This is a very, very, very bad use case of BGP. The only reason I put it here like this is just to get you guys familiar with the syntax, all right? That's all it is. If you haven't touched BGP a lot and you don't ever touch it, this could be a good way to kind of at least get the fundamental syntax down for this. But in this scenario, most likely you would use just static routing, as we're only really going to be advertising these individual loopback zeros out in this transport network, okay? And these loopback zeros, as you guys can see here, is going to be the tunnel sources. So these two tunnels, tunnel 100 and tunnel 200, are going to be sharing the same DMVPN tunnel source, okay? Because that's where they have the reachability to the other sites. We're also running phase 3 DMVPN. So let's just say that the same company, let's say they had a local file server here. They were hosting some local files, and these guys over here wanted to access those files. Instead of having to go all the way back up to the hub every single time and then back down to site 6, they could just have a, spoke-to-spoke communication here, pull the files over that way, makes things a lot easier, okay? So we'll be implementing that, which is, again, part of the exam blueprint. Now, these PCs here, I know, guys, you would never actually plug a PC directly into a customer edge service provider router, but this is going to simulate the LAN for each one of those companies without having to add a bunch of resources by adding a router, to the mix, okay? So it's a low-cost resource here. We can actually simulate a LAN connection, test reachability, test to make sure things are actually separated. And additionally, we can actually use those for some of the exam topics, such as DHCP relays and IP helper addresses, things of that nature. So let's just say that these guys are hosting IPAM servers up here at each one of their sites, and the DHCP pools are all up here. And these computers are plugging in, and they're expected to pull an IP address from their remote IPAM or DHCP server, whatever you want to call it. In order to do that, you're going to have an IP helper address because it's going across a different network. So it's leaving that current broadcast domain and going to a separate broadcast domain. Okay, so that's going to be a way we're actually able to implement that as well. But yeah, this is just to simulate it and keep the resource cost low. Got it? All right, so for the configuration piece of today's video, we're going to be starting out. I always like to start out with the transport piece first. Let's get our transport done. That way, and tested. That way we know that when we start adding the different DMVPN tunnels, we start adding routing protocols, we know it's not our underlying transport network here that's causing issues when things don't work the way we expect them to work. We can verify the transport is good. We can leave it alone, never touch it again. All right, so moving on to the configuration piece. What I like to do, especially in this scenario, whenever, a lot of these configurations are very, very similar. As you guys can probably assume, the sites are very similar to each other, just some slightly different IP addresses, autonomous system numbers, things of that nature. We're actually going to be templating everything out in a text editor of some sorts, okay? So again, I said I was going to start out with the transport network, and I'm actually going to start out with the core service provider simulation here, which is going to be router 3 and router 4. So I like to do all my configs in a text file so I can copy and paste them, make the minor changes, and then we can move about our business. It doesn't take us, 2 hours to set this topology up, all right? So we'll start out with the configuration piece. Now, I'm assuming that a lot of you guys already are familiar with a lot of these topics, okay? So this isn't going to be a series where I kind of go super deep into the subjects. As like I said, it's just a lab series. I'm just going to explain what the things are doing, not necessarily how they're working, I guess you could say, or diving super deep into details, okay? So we're going to configure T here because they're all going to be not enabled yet, and we'll set the host name as router 3. And then I like to do a couple little admin commands here that just make my life easier. Logging synchronous is going to make it to where the actual log commands don't overlap my commands that I'm typing. And then we'll do exec timeouts 00, so that way it doesn't time my sessions out while I'm running my mouth. And then we will do no IP domain lookup. That's going to allow our trace routes to just instantly execute like that. Cool. So again, we're going to set up the interfaces right now and the core BGP processes here for these provider edge routers. All right. So we'll go into interface gig 00 and we'll give it an IP address. Now, something to note here, guys, is that these are all like labeled. So 31 is from router 3 to router 1, 35, router 3 to router 5. It's all very easy to understand. And the last octet is always going to be that router's number. Okay. So for this, in this scenario, it's going to be 31.3. No shut. And we'll do interface gig 01, which is going to be our link between our IBGP neighbor, which is going to be router 4. No shut. And we'll go into gig 02, which is leading to site 5. And again, I know this part's going to be pretty boring. So again, if you're already, advanced, go ahead and skip ahead and start working towards this piece. Because again, this is for people that like to see the labs built from scratch. I got some requests for that. So here we are. And we have loopback 0 here. Alrighty. So our interfaces are all configured. Now what we have to do is set up this routing protocol or routing application. BGP is not a protocol, it's an application. So we'll do router BGP 250, because that's the AS. We'll do neighbor. We'll start out with our IBGP neighbor, which is going to be router 4. And guys, I'll have a PDF or a PNG to this topology in the files as well. So if you want to just open it up and see it on your second monitor or whatever, you can do so. So you don't have to rely on me moving my window around here for you to be able to see the topology. All right, so we'll do 34.4 remote AS 250. There's another important command we have to add here too, which is going to be next hop self. So that's essentially going to say, hey, any routes that I'm advertising to you, just send them back to me, because in a typical BGP deployment here without this command, router 4 is going to see the next hop as what router 3 has as his next hop. So in this scenario, for let's say he was wanting to go to site 5, router 3, or he's advertising out, hey, to get to me, I am come to this link here, so 35.5. Well, he doesn't have any type of directly connected link to 35.5, and we're not going to advertise this into BGP. We're only advertising our loopback zeros in. Therefore, he has no idea how to get there. The packet's going to get dropped. All right. So this is an important command to run in this scenario alone. However, I said I would be cautious using it in larger scaled BGP deployments. Okay. So, and then the other neighbors we have here, we have router 5, mode AS 65005. We have router 1. And we have router 6 or site 6. And then we're also going to advertise our loopback here just to test reachability. All right. So we essentially have the initial configurations done. This should be really all we really have to add to these two service provider routers. Okay. So we'll take this, we'll copy and paste it into router 3 just to make sure everything took and I didn't mess anything up. And then we'll just copy paste, make the changes we need to, and then add it to router 4. All right, cool. So again, copy it, and we'll work on router 4 here. So I'm just going to change the 3s in these certain scenarios to 4s, okay? So gig 00 here is going to be 42.4, and then he is going to be 01 is 34.4, 02 is 47.4, and 03 is 48.4. Loopback will change these to 4s. AS stays the same. 34.3 is going to be our remote neighbor here, and then we'll just make these the same as those interfaces. So we'll do 48.8, remote AS 8, 47.7, change this to a 7. And then what else we got? 42.2 remote AS 65002. Change the network we're advertising out here, and we should be good to copy and paste this into router 4. All right, let's let that kick. All right, cool. So now we need to actually establish BGP, and we'll set up the interfaces and the base BGP connectivity to our hub sites, okay? We'll basically just do essentially the, BGP, and that's it. We'll work on the DVPN and the routing protocols in a bit. So a lot of this stuff can stay the same. So again, for this video specifically, we're not going to focus on any of these interfaces here. We're not even going to configure them yet. Those are going to be waited. Those are going to stay for another video for route redistribution, things of that nature. Right here, I'm only focused on the actual edge routers. So we can take up to gig 00 here and take that down here. Change this to router 1. This is going to be 31.1. And then we have his loopbacks. So, I'm sorry, 10.1.0.1. And 1. And his router BGP process, or his AS, is going to be 65001. And we're going to add the single neighbor we have. That's all we have is one neighbor, 31.3, remote AS 250. And we're going to advertise our single loopback here, so loopback 0. All right. Now I should be able to copy these into router 1. See, that's why I add that exact timeout, so it doesn't just time out on me in the middle of me doing stuff. Okay, cool. So BGP setup here. Let's do the same thing on router 2 because we know these devices are very, very similar based on our topology. So we'll move this over here so we can get a visual. And we will work with router 2 here. We'll change this to 42.2. Change this to 10.2. 1, 2. And then 2. And then we'll have 42.4. And we'll advertise that out. See, guys, that's kind of why I do the templates because, again, it saves us time. As far as configuring goes, a lot of this stuff is very similar. And I don't like to waste time here. So, all right. Now we have that set up. Let's go ahead and start working towards our individual sites. So site 5, again, we can take up to here. Actually, we can take a good amount of this and put this here. So we'll create some space here for the other interfaces that we have because we are going to actually advertise those into EIGRP later. So we'll just set them up now. But there's one thing we have to do first here. And that's going to be to actually get our VRFs defined. So if we're going to do all the interface configuration now, let's go ahead and define our VRFs. All right. Because as you guys know, if you add a VRF to an interface after it's already IP'd, it's going to clear the IP address, causing you to do double the work, and we don't want to do that. So let's create some space here. To create a VRF, you're just going to do VRF definition and then the name. So we'll do comp A for company A, and I'll change that in the diagram that you'll have. It's just going to be a pain trying to type that out all the time. Address family IPv4, and we'll do exit. And then we'll do the same thing for VRF definition, comp B, address family IPv4, exit. Now we can move these interfaces back up here. And we have gig 00, which is going to be in no VRF because he's in the transport network, which is going to be part of our global routing table. So he's going to remain outside of any VRFs. So we'll do 35.5 here. And then for interface gig 01, he will be inside of a VRF. So as you guys can see, it's color-coded pink, means he's going to be in VRF A, as well as that loopback 1 is going to be in VRF A as well, company A. So VRF forwarding, we'll do comp A, IP add. Let me space this over so you guys can... IP address is going to be 192.551.5. No shut. Then we'll do interface gig 02. This is going to go in VRF forwarding company B. No shut. All right. Working through our loopbacks here. Loopback 0, global routing table. It's fine just how it is. In loopback 1, though, we're going to put it in VRF forwarding comp A. And then int loopback 2, VRF forwarding, comp B. Whoops. Give it an IP. We're actually going to do 10.2.1.2 or .2.2. I'm sorry, 10.5.2.5. I got confused there for a second. And we'll change these to 5s. And boom. Cool. Let's modify this BGP statement here. Make sure you put the right AS and the remote neighbor ID. And we'll advertise only our loopback 0 within BGP. All right. Same process is going to happen for the other routers as well. Let's make sure everything took. Sweet. Everything is good. All right. Let's do the same thing for router 6, 7, and 8. Again, I know this is very repetitive, but there are people out there that do get value out of seeing this happen. So feel free to skip ahead if you're already dying of boredom. So we already have this baseline configuration done. We can just kind of change up some of the smaller things here. So the interfaces are going to stay in the same VRFs as the other sites. We just need to change these 5s to 6s. And the AS as well as the neighbor. 36.3, and then we'll change this. And this should be good for this guy. It was pretty quick. So router 6 was a quick one. All right, that is done. Let's move to router 7 now. And he has a different BGP neighbor. So I have to watch out for that. It's not going to be as quick as the last one. Change our host name. Change this to 47.7. All this stuff here can stay the same though, as far as just editing the 6s to 7s. I'm trying to do this as fast as possible because this is actually, the not so fun part about this process. All right. Sweet. Router 7 configs are done. Okay. Let's work on router 8 now. Router 8. We'll change it to 48.8. Oops. Eight. All right. Now the bare bones configurations should be done. As soon as I put these in here. And we can actually go into router 1 here and just check real quick and see what we have going on. We do a show IP BGP. All right, we can see that we have the different BGP networks that are being advertised out. And if we do a show IP route BGP, we can see what we have reachability to through going to 31.3. So I should be able to hit my sites 10.6. And the reason that 7 and 8 haven't came up is they're probably still converging. So they will probably come up very soon. And we'll ping with a source of loopback 0. Can I type today or no? Cool. We got reachability there from our loopback. Now let's see, 505. Sweet. Let's see if 7s came up yet. Has not. The process of me pausing the video to wait for those routes to pop up and then me resuming the video, I didn't unmute my mic. So therefore I recorded the entire rest of this video with my mic muted. And so now I'm coming back. I had to delete the configuration to get up to the point where we were at and come back to it. So we do have reachability to all the different sites now. As you can see on each one of these devices, I was pinging the different hub tunnel sources. So now we can move on to actually configuring those DMVPN tunnels on the hubs and then on the spokes. We're also going to be configuring the routing protocols that we're going to be using over there as well. All right, so let's go ahead and get started. So the first thing we do is we actually need to define, we're going to define a crypto ISACANT policy. So we'll just do R1 here. We'll do crypto ISACANT policy 10. And we'll do encryption AES. We will do authentication is going to be pre-share. We're going to use pre-shared keys for this. And then we will do group Diffie-Hellman group 5 and then hash MD5. Now we'll set that ISACANT key itself. We're just going to do Cisco 123 address saying, hey, anybody can use this key. Now we'll define our transform set, which is essentially going to define the IPsec parameters. So we'll do transform ESP AES, and then we'll do ESP SHA HMAC. And then we'll do mode transport exits. All right, and then we'll do crypto IPsec. I just tried tabbing like I was in a Cisco router. Crypto IPsec profile DMVPN, and then we'll do set transform sets transform. So as you guys can see, we just linked this transform set here to this IPsec profile. All right, so now that our IPsec configuration is all good and dandy, let's go ahead and set up our tunnels. So for router 1, he's only going to have one tunnel, and it's going to be interface tunnel 100. Do IP address 192.168.100.0.1. Okay, now we're going to set the MTU of the tunnel 1400. This is going to be set a little bit lower than the regular Ethernet MTU so that we can allow for the extra IPsec/GRE overhead. All right, IPTCP adjust MSS is going to be 40 bytes lower than that, so 1360, which is going to allow for the 20 for the IP header and 20 for the TCP header. All right, and then we'll do an IP NHRP authentication, and we'll set this to site 1, basically saying, hey, you have to have this key or this code in order to actually come into my NHRP instance. And then we'll do a map multicast dynamic, since he's the hub, so he's saying anybody can put it in my table. Dynamic, we're not statically setting anything. We'll set the NHRP network ID to 100, and we'll set the hold time to 300. And then we will do IP NHRP redirect, since we're running phase 3. And then we need to add a tunnel source. So tunnel source, loopback 0, of course, and tunnel mode. And then we also need to set the tunnel key. And we'll do tunnel protection as the IPsec profile, which we call DMVPN. All right, so this looks good. Now let's set up our routing protocol here. We're going to be actually running over this DMVPN tunnel. And that's going to be EIGRP. And we're going to use EIGRP name mode here just because I like it a lot better. And it's the way forward, I guess you could say. So address family IPv4. And there's actually a shortcut you can do here, guys. So instead of having to type IPv4 unicast autonomous system whatever, we can do address family IPv4 AS300. That's the AS we're using. And it'll bring us into it. It's like a little shortcut. So we're going to put all the interfaces to passive by default. It's a good practice. And then only allowing in the interfaces we actually want. So we'll do AF interface, tunnel 100, obviously. No passive interface. We also have to add no split horizon here to tunnel 100 because he is a multi-point interface here. And we want him to be able to advertise router 6 or site 6, router 6 routes back to router 5, especially if they're going to be doing, site to site, spoke to spoke hops. So let's actually do an exit here because we're going to have to do an exit address family. We'll do no split horizon. And then we'll do AF interface, loopback 1, no passive. All right, and then we will actually advertise our networks here. We'll advertise the tunnel interface. And we'll advertise our loopback, 10.1.1.1. And that should be good. Okay. We applied the IPsec profile. We have the routing interface. All right, everything looks good. Let's go ahead and copy and paste and see if it actually takes. Boom. Okay, what just happened? Did I do something wrong here? You guys see that? What's happening? Hold on. Let me let's see what's happening here. Do I have end somewhere in there or something that I don't know about? An end or log out? Did it even add the tunnel? It's not adding anything. Let's try pasting bits and pieces. Okay, so I forgot crypto IPsec transform set here. It's a good thing I caught that. That might have been why I was like bugging out. I'm not sure, but let's try just adding the rest in here. I messed something else up. Crypto. I thought I changed that. Crypto IPsec transform set. Oh, I did take it. Okay, cool. Sweet. All right. So this all took. Everything's good. Now we can copy this We don't need the EIGRP statement. We can copy this stuff here and move over to router 2 because he's going to have the same crypto policies and parameters as router 1 because we're going to be sharing those IPsec profiles on both tunnels on the spokes, so to make sure they actually match. All right, so all this stuff can stay the same. Crypto IPsec is there. Cool. We'll change this to tunnel 200. 200.2. Change this to site 2. 200. 200. All right, and there's something else we have to add here. Since I said we were using EIGR or running OSPF over tunnel 200, and this is a multi-point interface, we actually specify through IP OSPF network point to multi-points. That needs to be there. Let's go ahead and define our OSPF routing instance here. So we'll do network 200.0.0, area 0. Everything's going to start in area 0. Eventually, we will move to multi-area, but for right now, we're just going to stick to area 0. Keep it simple, sweet, stupid. All right, nice. So let's go ahead and copy this and put this inside of router 2. All right, sweet. Everything took that time. Now, when we start configuring the spokes, it's going to be a little bit different. What we can take is we can take these crypto configurations, though, because those are going to stay the exact same in all the spokes. But when we get down to the tunnels, the spoke tunnels are much different than the actual hub tunnels, okay? There's a few more configurations we need to make, and it's going to depend on what tunnel it is. So we'll do interface tunnel 100. We'll start with tunnel 100. It needs to go on VRF comp A. All right, because it's the company A tunnel here. So we will do IP address 192.100.0.5 for router 5. And then we're going to do IP MTU 1400 for the same reasons we did that on the other tunnels as well. And 1360 again, same thing. We have to make sure our authentication is set to the same or else it will not come up. And we'll do IP entry map. We're going to map this tunnel interface. So our hub tunnels interface to the transport network that we're reaching them through, so their tunnel source, right? And then we're going to do the same at multicast, and then we're going to say, hey, we're multicasting to this guy here. Network ID is going to be 100, same as up there. Doesn't have to be, though. Hold time 300, NHS, NHRP, NHS, and the tunnel IP. We'll do IP NHRP shortcut to enable spoke-to-spoke phase 3 DMVPN. Set our tunnel source, loopback 0. We will set the tunnel mode, GRE multipoint. Set the key, can't forget that key. And then tunnel protection is going to be IPsec profile DMVPN shared. This shared word has to be here. Since he's running 2 tunnels that are using the same DMVPN IPsec profile, we need to add shared here, or else it's not going to allow this profile to be added to multiple interfaces. All right. So tunnel 100 looks good to me. Let's go into interface tunnel 200. And in this instance, we can essentially copy and paste. Okay. So once we have this done, copy this, paste here. We will do 200.5 is going to stay there. We'll do site 2. Change all these. Okay, tunnel key 200, and then that looks good. All right, now the thing we have to add here, though, since we're running OSPF, like I said earlier, we actually need to specify this is a point-to-multipoint network. Oops, point to multipoints. Otherwise, it'll come back and say, hey, you're running the wrong OSPF network type, blah, blah, blah. Okay. So right now, all this looks good. Let's start working on our routing protocols now. So router EIGRP site 5, address family, IPv4, unicast. We're not going to short this one because I'm not sure if the shortcut works with VRFs. Unicast VRF comp A, that's very important. Autonomous system 300. And then we go to if interface, default, make it passive. If interface tunnel 100, it's going to be no passive interface. I always forget to actually do the exits here. If interface loopback 1. AF interface, what was that? Gig 01 over there? Gig 01. All right, so we'll do gig 01 here, and then we'll do no passive interface again. Exits. Let's advertise our networks. Network 192.100.0.0. Advertise our 192.551.0.0. And we will advertise our loopback, which is 10.5.1.5. All right, so EIGRP is done. Now we should be able to go into router OSPF 1 VRF comp B. That's how you do VRFs for OSPF processes, okay? We'll do network, and we're gonna advertise tunnel 200. Area 0, we'll advertise our loopback 2, or our second interface 52, or 5, 52.0 to area 0, and then our loopback 10.5.2.5, area 0, and then we should be good. All right, so let's just make sure we have things here. We have the OSPF network. We have all of our networks being advertised here. And the profile's added. Authentication looks correct. All right, cool. So let's go ahead and try adding this in and just see if we get an adjacency. All right. Into router 5 here. Comp T. Boom. Of course. I always jack something up here. So under router, so let's just do this. Under router EIGRP site 5, it was it was under the this network 192.551.0. I felt like there was an extra 0 there when I was doing it, but I just didn't notice it. Yeah, there is. Cool. All right, sweet. So as you guys can see, we have an adjacency with the EIGRP. Do show IP EIGRP VRF comp A neighbors. Do we have anything with OSPF? We don't have anything with OSPF. Why not? So going to do a little troubleshooting here. So Tunnel 200 is using Site 2 as his NHRP authentication. He has network point to multipoint for OSPF, the right tunnel key, and we are in fact advertising that interface out in OSPF. So 192.200.0.0. We're advertising our loopback. All right, so let's just do a, let's check router 2 here. Do we have anything crazy going on over here? Int ton 200. Site 2, 200, tunnel key 200. Did I change the tunnel key? Check over here. Tunnel key 200, loopback source, NHS. Everything looks good to me. Let's see here. Oh, you guys know what it is? I didn't change the VRF group. So I'm going to reconfigure this from scratch here. Oh, man. So it's going to router 5 again. And let's do this again. Now, hopefully, we should see an OSPF neighborship pop up. Maybe? VRF forwarding comp B. Am I getting anything on router 2? No. Tunnels on comp B. I do have reachability. So what do you guys think the issue is here? So we have DMVPN shared as a protection profile. So we can do a debug IP packet or debug. We can do a debug crypto, but let's just do a debug IP packet here first and just see what we get. And so it looks like we're seeing multicast messages for EIGRP going across. We're seeing OSPF. So let's go ahead and UAll. So we see here that across tunnel 100 encapsulation failed for 192.100.0.5. Local NHRP redirects. I'm looking for my. So we just got a neighbor somehow. So it finally came up. IP OSPF neighbors. Maybe it just took a second to converge. It's been up for 2 minutes. So we were freaking out for nothing. We did have to change that though, guys. We did have to change the forwarding mode VRF defined in tunnel to 200. So that's an important thing. So now let's go ahead and copy these configs over to the other routers within the other spoke routers. So do here, we'll change this to site 6, change this to 661, and I'm kind of doing this like backwards here, but let's go up to our tunnels here. Let's change this to .6. All this can stay the same. We change this to .6. All this can stay the same. All right, cool. And it's in the right VRF now. So this should be good. We should come up on this almost instantly. Cool. All right, so we have EDGRP and OSPF instantly came up. Good news for us. So let's go ahead and do the same thing for router 7. Oh man, really? Here, router 7. So we'll start up here. We'll do 7, and then 7, and then 7. We'll do site 7. Make sure we're advertising the right routes here. 7 and 7.1, and then 7, 7.2, 7.2. All right, cool. So let's do the same thing again. Again, guys, I know this video has not been very exciting. Hopefully the next ones will be better. Hopefully the lab videos are a little better for you. This is literally just the meat of all of this. We got an EIGRP and an OSPF adjacency. So let's go ahead and do the same thing for router 8. And then we should have all of our sites up with each individual tunnel. They will have spoke-to-spoke connectivity over phase 3 DMVPN. And we'll demonstrate that really quick before we head out as well. I think that was all we had to change, right? Site 8. That doesn't really matter, but let's keep it consistent across the board. And let's drop this in and see if we got our adjacencies to come up. And they both came up. All right, so now if I do a show IP route, I'm only going to see the BGP routes because that's my global routing table and I'm running VRF. So I need to do a show IP route, VRF, and then the VRF name. So for company A, comp A, I'm seeing the EIGRP routes. So I'm seeing router 5's routes, router 6's routes, and router 7's routes. I'm learning from EIGRP, which is exactly what we want. Great. Same thing with the loopbacks. All right. The .1 loopbacks. So now I'm going to do a show IP route VRF comp B. I'm going to see routes from the different sites on their 2 loopback interfaces. So we actually advertised out loopback 1 or loopback 0. I'm sorry, loopback 1 inside of router 2, which is fine. So that's the only one that's going to have a .1 in it. The rest of them are going to be .2s, and then we should see those little LAN interface, those LAN networks as well, which we do. That's good. If we do a show DMVPN, we should only see our 2 peers, right? However, if I was to ping, let's just say 10.1.5.1 with a source of loopback 1. Oh, I got to ping VRF. Excuse me on that, guys. Let me close out of this Epic Pen so I can actually control Shift 6. So ping VRF comp A 10.5.1.5 source loopback 1. And then I do a show DMVPN. As you guys can see, I have another DMVPN peer there. And it through the dynamic tunnels. All right. So we have phase 3 DMVPN working across all the different sites. Everything is great. We're not doing anything back here yet. Remember that. So the troubleshooting tickets will be in the video that is posted at the same time as this one. Check that out. Let me know what you guys think about that. I'll go through the tickets and explain how to set the lab up and everything like that in that video. I hope you guys got some value out of this. For those of you that like seeing topologies build up like this, it's not the most exciting thing for me to watch personally, but like I said, it was requested, so I delivered. Hope you guys enjoyed, and I will see you in the lab video.